Okay, so we have the function f of x equals 3x plus 1 over 2x squared plus 1. Now, to find the derivative of this equation, we need the quotient rule. So the quotient rule states that the derivative of this function will be low, derivative of the high, minus high, derivative of low, all over low squared. So that gives us low, 2x plus 1, times the derivative of the high is 3, minus high, 3x plus 1, over the derivative of the low is 4x. And all over 2x squared plus 1 squared. Okay, so after your simplification, you're going to get f prime of x equals negative 6x squared minus 4x plus 3 divided by 2x squared plus 1 squared. Now, this is a really easy problem because we only have one term in the numerator and only one term in the denominator. So the next problem is going to be a little bit harder. So something totally new in AP Calculus, new from pre-calc, is the implementation of trigonometry with derivatives. So the derivative of cosine is negative sine. So let's just say the inside is u. So the derivative is negative sine u times u prime. Okay, so we have low, 2x, d high, remember negative sine of u, 3x plus 1. Now u prime is 3, so low, d high, minus high, which is just cosine of 3x plus 1, and the derivative of the bottom, which is just 2, over 2x squared. So after we found the derivative of the function, we got a very long equation. Now we simplify things a little bit. Just remember that the negative 2 out here, we multiply that by the whole numerator over 4x squared. So we simplified this equation to get to this. Because on multiple choice questions, most likely this will not show up. So to prepare you for a multiple choice question, we will simplify. So f of x equals secant of 2x divided by 5x minus 2. So this is not the basic equation of secant of x. So it use secant of u. So the derivative of secant of u is tangent of u times secant of u times u prime d of u over d of x. So we have low, 5x minus 2, times the derivative of the high, tangent of 2x, secant of 2x, times the derivative of the inside 2x is 2, so 2 over there, minus the derivative of the high is secant of 2x, times the derivative of the low is 5, all over low squared, 5x minus 2. Now, to simplify things, I crossed out 5x minus 2, 5x minus 2, got down denominator, and I factored a secant of 2x, and then we have this on the inside. So the simplified answer is secant of 2x times 2 tangent of 2x minus 5 all over 5x minus 2. Okay, so f of x equals 2x squared plus 1 squared over x minus 2. Now this one's a little bit more difficult because in the numerator we're going to need to use the chain rule within the quotient rule. So remembering the equation low d high minus high d low over low squared is the derivative of a rational function. We have low x minus 2 times derivative of the high, which is bring the 2 out in front, 2 times 2x squared plus 1, times the derivative of the inside, which is 4x, minus high, 2x squared plus 1, squared, times the derivative of the denominator, which is just 1, over the denominator squared, which is x minus 2 squared. Now, we will not need to simplify this because this is a short answer question. If it was a multiple choice, you need to simplify to get your answer to match a multiple choice answer. Okay, so this problem is a little bit more difficult because we have trig and we have natural log within the quotient rule. So the same idea still applies, except we have a trig and natural log. But it's going to be easy because watch this. So low, cosine of x, derivative of high. Now, the derivative of this is, let's just say 2x plus 1 is u. So we have u prime over u. So natural log of 2x plus 1, the derivative of that would be u prime 2 over 2x plus 1. Minus high, which is natural log of 2x plus 1, over the derivative of the low, which is negative sine x, times 1, but we won't write times 1. low d high minus high d low over low squared. Now, low squared is just cosine of x squared. Done. Okay, so f of x equals sine squared cosine of 3x divided by secant of x. So this one's a little bit harder because we have trig on the numerator and the denominator, and we have the chain rule in the numerator. And we have composition of functions, sine squared cosine of x of 3x. So now we have, so this can be written as sine cosine of 3x squared. So low secant of x. Now this is where it's going to get tricky. Derivative of the high, so move the 2 out in front. Sine cosine of 3x. Now we need the derivative of the inside, which is going to be derivative of sine is cosine. Cosine of 3x. And now the derivative of cosine is negative sine of 3x times the inside, which is 3, so times 3. So this is just low derivative high. Now minus high sine squared cosine of 3x d high. Derivative of secant of x is tangent of x times secant of x times 1, because the derivative of x is 1, all over secant of x squared. Okay, so using the quotient rule, we can find the derivative at a point of a function. So we'll have y equals 3x plus 2 over tangent of x. So the derivative will be tangent of x times 3 minus 3x plus 2 times secant of x times tangent of x over tangent squared x. So to find the derivative at a point, we'll go graph, and we'll go second calc dy over dx, and we'll plug in x equals 2, and the derivative at x equals 2 is about negative 11.